But welcome, everyone. I am happy to introduce this talk. Really looking forward to it as somebody who has worked on at least 2 different serverless application frameworks, very much on purpose, and you know, with architecture and planning. I am really interested to hear how JJ ended up creating one by accident.
Yes, I did.
And so with that, let's welcome JJ Asghar.
Thank you. Yeah. Thank you, Fuzzy Chef. Yes, I don't actually know him as Josh. I know him as Fuzzy Chef. Yes, hello. I have a question already. Sure. That's really your email? It is. Yeah, I was about to say that. Yes. I mean, that is awesome. Thank you. Thank you. Thank you. Yes. So, hi, I'm JJ. And yes, I do really have the email address of awesome@ibm.com. If you know anything about IBM, you know how ridiculous our emails are, and it's amazing what you can do with the correct paperwork. So. I found the correct paperwork, and surprisingly, that one was not taken, but DevOps was. But that's a different conversation for a different time. You can find me at JJ Asghar more or less everywhere. So find me there. It's pretty straightforward. I'm on Mastodon as at JJ Asghar or at mastodon.social. I've made the move. I'm a developer advocate, which means I have no idea what that means. Basically, I get to engage with developers, and thank you for being here. This is a nice little fun story that hopefully you'll be able to identify. Maybe you're on the same journey and you don't even realize it. This is targeted more at production level or like infrastructure level people. There is some Python involved in this talk, and we're going to look at some code. You can make fun of the code because it was when I didn't actually understand Flask and I ran it as a Flask app. So I know Code Ranger in front of me is going to be like, JJ, you're an idiot. But it's fine. It's fine. Oh, and also I like interaction. So if you have questions, just like Justin did there, Rothgar did, don't hesitate to raise your hand or just shout something out. I'm also a streamer, so I'm used to answering questions of how do you Kubernetes to what be computer? And be able to pivot and answer that question really easily. And all the streamers in the room giggle to that because they know exactly what I mean. Wait, what? Your first question is probably, how is this possible, right? Like, why? How do you accidentally find yourself building a serverless application? It's the journey from the normal software development process, right? Like you're sitting there, and you're trying to build, trying to scratch an itch, and over time, it's amazing how eventually you can get to the point where that itch is so large that you have a full-blown application. We're going to talk about the iterations of what I walked through, and again, hopefully you'll see where that fits in that space. So the core problem is, as a developer advocate, at least last year and the year before that, and especially in 2019, one of the largest challenges I have was to teach people things, right? Like, my goal is to get people to use IBM Cloud at the time, but now it's more OpenShift as a whole, but I still need to teach people stuff. And to do this well, you need to create workshops. You need to have people actually putting their fingers on keyboards to learn something, because we can talk about what a pod is or what a node is, but until you actually see where that fits, you don't fully grasp it. And if you didn't know, IBM Cloud is designed to be very production-like. It comes from the world of something called software, and they're not designed to be ephemeral, right? One of the problems with IBM Cloud as a whole is that you spin up a Kubernetes cluster or an OpenShift cluster, and they expect it to be there for long periods of time because you're supposed to iterate inside of the cluster. Well, that goes completely in the face of workshops, because as someone who's traveling around the world doing workshops, I could be doing 3 workshops a week, right? So I'd be iterating through all of these clusters constantly. And the amount of time and effort it would take to spin up these clusters were ridiculous. We often create systems to get around these kinds of problems, right? Like we start with something simple and we build something off of it. But recently in updating these systems, in the deployment process of such system, I realized I can create a full serverless stack as it grew. This was originally a blog post that I wrote, and I turned it into a talk because it felt more like something I wanted to tell people and kind of interact with them to say that, hey, believe it or not, you can probably steal some of these ideas. I also get to show you off some really neat IBM technology that not even as an IBMer, but as just an engineer, if you find the right place for these things, it actually makes your life really easy, and it's stupid cheap, which is something that most people don't say about IBM, just saying. Maybe, I don't know. So let's talk about the iterations of what went through. By the way, I haven't even mentioned this yet. To my right, there's another room. A man named Mofi Rahman is speaking. He was actually on this whole journey myself, with me, hand in hand. It's very funny that I'm doing the talk about the journey that we took together. He works at Google now, and he's a good friend of mine. I love him to death, but it's really funny that I'm telling our story, but he's telling something completely different over there. So it's amazing how that works. Who's a sysadmin? Who's a DevOps professional? Who loves Bash? Yeah, but Bash is serverless, that's right. Of course, the first thing we did was Bash, right? Like, you get told, spin up 30 clusters, right? What are you gonna do? A fucking for loop and a Bash script, right? Just run it and run it. I will say, I did cause a global outage at IBM Cloud because of such for loop, but I'll talk about that in a little bit more in a little bit. There's an application called IBM Cloud, just kind of like the AZ for Azure or AWS CLI. There's the same one for IBM Cloud, which does a ton of stuff. But the challenge is it's not actually that easy to customize. So you have to write a bunch of wrapper code around it to be able to do what you're looking for. I'm not going to spin up 30 clusters for a class of 10 people, right? Like, I need to be able to move that number around. And IBM Cloud actually was really hard to write all that stuff out to templatize it. So if you can read this, this was actually the first script that we wrote to run creating a bunch of IBM Cloud, Kubernetes clusters inside of a specific zone, all the same size. And we got the budget for it. That version, you just switch it to OpenShift or whatever version of Kubernetes you're doing. As you can see, this is pretty old, but that's fine. Like, the story is the same, right? But it was just literally a Bash script that was a for loop off of so many numbers. It ran through every single zone. We had an issue in IBM Cloud where we had VLANs specifically tied to certain things you had to pull from, which was actually a really big problem for us. So as you can see, that crazy public-private line up there, where there's an awk and a grep inside of it, you know you failed. That was supposed to be a joke, but okay. But as you can see, you kind of just dump it in there, and as you notice at the very bottom there, it says success and failed. At the time when we were running this, clusters could fail for reasons. We don't know why they would fail. They would just kind of fail. So if something failed, we had to investigate. But more importantly, this was our first iteration. This was our next one. And I realize how small this text is, and I apologize for that. But the most important part is that sleep up at the top. And that's what I was talking about a minute ago with how I accidentally took down IBM Cloud, was when I would run this, and as you saw, it's just a background process, right? Like, we threw it down with the ampersand at the back right there, just to go shove it out there. Before we had that sleep in there, I would send like a request for 100 clusters, and it overran the API, which was bad. And we use Kubernetes and etcd as our backend for the requests for the IBM Cloud. So we would actually overrun etcd with too many requests. And it turns out I actually found a lot of problems with our design that way. So needless to say, we had that little sleep in there. Another thing, if you notice here also, we have this weird little filter tag. Over time, we ended up having to figure out a way to filter out clusters for different projects or different workshops we were doing. So that's what this became. And this actually highlights the problem when you decide to add a feature after you've done your initial release, because it's a completely different API, which was kind of a problem. So we actually had to send the request, then pray that the request would get processed, then send the request to the tagging API to find that CRN to be able to tag it with the name so our software could actually do the work. It was ridiculous, not gonna lie. But again, what is it at the bottom? It's just a for loop, right? It's just a for loop. So obviously this is not sustainable, right? Like, take a step back and think about it. Over this time, I'm just gonna throw a number out there. I don't know the exact number at the time, but let's just say there was like 30 developer advocates for IBM Cloud at the time, right? We were going all over the world. There's a bunch of people doing this work, and obviously me just running this was not sustainable. So if I'm running a bunch of requests against a workshop account, that only is me, right, running that thing. I might decide to take vacation. I might, get sick. So I needed a way to extend this more than just a for loop. And especially also we had naming collisions, right? If all of a sudden we have workshops in Tokyo and we all call all our workshops Tokyo Workshop, there's going to be problems, right? Like you can only have one name, Tokyo Workshop. And especially if you have two Tokyo Workshops, you're going to have Tokyo Workshop 001 or twice, which will cause even more problems. So needless to say, we had to find something more sustainable. So we came to the Ansible IBM Cloud Community Plugin. This was a mistake, not going to lie. We tried to leverage Ansible to be our driver because we thought we could kind of extract away all that bash logic and turn it into an Ansible playbook. But it turns out this community plugin at the time didn't even support Kubernetes. It didn't. Didn't support clusters at all. It only supported some very obscure portions of IBM Cloud that you could tell somebody just wrote that for that purpose and then shipped it as the IBM Cloud Community Plugin. So this was a no-go. But of course, Terraform has to come into the story at some point, right? I ended up leveraging Terraform for quite a while, but I didn't have a good way to keep all the workshops in sync. Because what is the one problem with Terraform? Still to this day, from what I understand, granted I haven't done it in a while, is keeping the state files in check, right? If you have 30 people looking for state files, you're going to get some weirdness going on really quick. Just because it was growing at the time, it was weird. It was just not great. I did end up creating a little Go app, though, that templatized out that for loop that you saw as a Terraform plan, as a nice proof of concept. I learned about, Go templating at the time. And it was cool. Like, it was a good POC. Never saw the light of day after my laptop died, though. So Terraform was a good shot. And it turns out, over time, we ended up leveraging a portion of it with another technology. But it's good to know that Terraform was there for a little while. So we went back to Ansible. It was... We figured we needed a more solid way, and if Terraform wasn't going to work, Bash wasn't going to work, we needed something. So we went back to Ansible. And it turns out Mofi is the one who actually did it, created his own plugin, community plugin, that just does exactly what we needed to at the time, which was to request clusters. We put it in front of something called AWX. Does anyone know what AWX is? Yeah? Do you know what Ansible Tower is? Does that make more sense? Okay. AWX is the upstream version of Ansible Tower, which is the open source version. And I'm not going to lie, it's a nightmare to run. It's a nightmare to run. But we ended up using it because for whatever reason, I couldn't find money or even the right Red Hatter to give me a license for Tower. So we just put AWX in front of it and spent about 6 weeks learning how to run the damn thing. Yes, Rich? So I will say that in just a second. So we needed a way to be able to fire off a request and have a command and control, which was what AWX was, to request all these things through an Ansible playbook. So if we need to make a change, we would play with our Ansible playbooks, AWX would run it, and then KubeAdmin was actually a little Go app that Mofi wrote that allowed us to get a, for lack of a better term, dashboard view of all our clusters. And this is really important because at the time, and I think still to this day, from logging in to deleting a cluster, it would take approximately 17 clicks, and also probably writing in a name to verify that. Now, if you had to delete 100 clusters a day, do you want to do that? No. So Mophie ended up writing a really nice little Go interface that ended up just basically being a for loop again in Go, but it was a way for us to fill out, for lack of a better term, a form to go to AWX to be more command and control to spin up the clusters through AWX, and when we delete it all, we can search really easily through all our clusters and then delete it, which was really nice. It really did, at the peak of us doing all the workshops, it really did make our lives significantly easier, and I didn't have to wake up at 3 in the morning to spin a bunch of clusters up for Tokyo anymore, which was really nice. So we ended up we had a really nice foundation now using AWX and Kube-admin now to obfuscate away all of that bash scripting, all that Terraform and all that. Now we have this Ansible playbook that just requests clusters, and we have, Kube-admin as my interface into it. Now I don't have to do it anymore because I can now just give somebody a link and say, hey, you need to spin up n number of clusters for your workshop. Here's literally the command and control. It goes to the correct workshop or work group, and it just charged back to the correct people. It was great. But the problem was we didn't really have a way to create a pipeline of these requests, right? We would start getting people to come in, and they would be like, hey, JJ, I need 15 clusters. Hey, JJ, I need 20 clusters. I needed a way to create a pipeline of this stuff. And that's where the Cloud Functions came in. The first thing we did was we took a enterprise GitHub issue. IBM runs fully on GitHub Enterprise. All our stuff is internal inside of GitHub. So it was very natural for me to grab GitHub Enterprise and throw that in there. And we built something off of another project to start validating requests. One of the problems we had was that we could only cap clusters to 75 per request. So I couldn't have someone come in and spin up 1,000 clusters, right? It had happened. Some jackass did that before. That was a very large bill. So we had to find a way to cap that number. And we used IBM Cloud Functions, which was just basically a serverless application that would or a serverless Python script that would just sit there and get a webhook of the request and check against everything to make sure that the correct versions that what we wanted. So when I had to just copy and paste and throw it into the thing, it would just work. So you can't, it made our lives significantly easier. And this was the first step that we realized that we were starting to build a serverless application because we leveraged Cloud Functions. So I do want to take a quick little aside real quick and talk about schematics. This is a application in IBM's portfolio, which is basically the best way to describe it, and this is a little bit old information, so don't yell at me if I'm wrong here. But at the time I was using schematics was a free version of Terraform Enterprise. So when you needed to start sharing Terraform state plans, there's a Terraform state files with multiple people. That was the core value of Terraform Enterprise with workspaces, or workspaces, sure. Schematics was IBM's answer to that. We created a free service called Schematics that allows you to shove your Terraform plan and it owns your state file on IBM Cloud, so you can have multiple people be able to take the state and verify it, which was really neat. It didn't obviously make HashiCorp very happy, but it worked, and we ended up using it for portions of our iterations at one time. I would be remiss not to mention that it did not work in our long-term solution, but it did actually exist. So after we started playing around with Cloud Functions to do the validator, we released something called Code-Engine as a company. And what Code-Engine is, especially for this audience, it's basically Lambda, right? It's basically Lambda in a nutshell. It's IBM's version of it. It's surprisingly powerful. It's built off of Istio and runs, is all open source software too, with just a little bit of IBM on top of it. We started building portions of our app into small little functions and building the containers and putting them inside of Code-Engine. And I'll show you the output here in a second. But the idea was, now that we had AWX and kubeadmin, we needed to break down the portions to be smaller because AWX was so heavy-handed. It really, truly was. So we needed a way to remove ourselves from using AWX and have a little bit more agility. Back to the nightmare of running it, we kind of walked away. And we started looking at Code-Engine as ways to scope down responsibilities for different things. Whoa. So this is actually what we ended up creating. If you can see all this, we would have the actor, GitHub Enterprise, Cloud Functions, Code-Engine, Kubernetes, and then there's schematics down in the corner, and then there's our cloud. So what we ended up doing is the actor would put in a request to GitHub Enterprise as an issue, which I'll show a demo here in a second. The Cloud Functions would validate to make sure that you weren't asking for 1,000 clusters or whatever. Then there was another service called the cron issue tracker right there that was running Code-Engine every 15 minutes, a small little app that was the exact same thing of GitHub Validator, but with a couple more features inside of it. Scrape that thing, and then send a request to the Grant Cluster API. And then if we said, hey, is it, the Grant Cluster is the way to log into the system. Then if we were like, hey, Kubernetes or OpenShift, we would send it to the Gen 2 API, which was what we leveraged schematics for. And then schematics would run Terraform and spin up the clusters for us. If it was a Gen 1, we would go directly to AWX and then send it out to IBM Cloud. That's a serverless app. What is a serverless app? It's a Rube Goldberg machine. If you haven't realized that yet, that's the joke of this whole talk. What we ended up creating was a very advanced Rube Goldberg machine to request for clusters that was, in essence, a bash script. So the most important thing to realize out of this is we leveraged multiple portions of it, and we've actually removed the AWX portion now because there's no real need for it anymore because we can just call directly to the cloud. But the idea is that when you start looking through all these different things to build your application, a serverless app is just a Rube Goldberg machine. So let's actually see some code, and I'll show you actually what I've actually done here and see how it goes. Okay. So first thing first, if I can find my mouse. This right here is one of the requests, right? Like, granted, this was in 2022, but back to that issue tracker validator thing, right? We would ask them to fill out all these things, like 40 clusters here, 2 workers, the type we needed, what region, start time, end time. It would actually parse out all this information for us. And then, if there's any issues with it, it would send it. And we use the tagging system, so when the cron issue tracker would read from it, it would look for specific tags to know what to do. Then it would send out a nice little friendly reminder. There's that Grant Cluster app, so we didn't actually have to put any, give any rights to anybody because we had a nice little, small little app that would just do that for us. And then, when it was done, this one's actually a bad example because it was run multiple times, but you get the point. And as you can see, we ended up running 605 of these over a couple of years' plans. So from me doing this honestly on a daily basis to automating this away, it allowed me to just kind of make sure that when things broke, I would pay attention, but this would just keep running that way. Then, so this is our, excuse me for a second. So this right here is really small. Let me make that bigger. Oh no. So this is my example one. This is the Gen 2 API request here. Oh, what? Stupid. Ah! It's amazing how hard this is when you're trying to do it live. Here we go. So this is, we ended up creating this little serverless app on Code-Engine, but who sees the joke here? Does anyone get it? Exactly. What is this? It's just a post command that's literally just running a bash script. So out of all these iterations we created, we just took away the for loop, gave it a post to be able to just do the IBM Cloud run to make that thing happen. So all that work that we did to learn all these other processes and all, we ended up just creating a container that sits there and waits for the request. So we have all these other little things that pulls all that information out from GitHub Enterprise, then shoves it as a post request to a waiting serverless app that n number of clusters you need, it just spins up n number of those workers, of those requests, and then shoves them all off to IBM Cloud to make it pop up. So that's the gist of the whole story here is what is system administration, but just still a for loop. Yeah, I'm sorry? Yeah, exactly. That's right. This is now SRE. I do want to say this is Web 2.5, not Web 3, 2.5. But if you actually want to see, I will say this is a horrible Flask app. Do not take this as an example. But if you want to play around with it, it is actually on IBM Avocados, if you ever need to see it. And here's an internal one here. This is the actual one we run internally that's still sitting there. As you can see, there's a little bit more logic around it, but it creates the post, and then we ended up adding a delete cluster request also inside of it too, which was neat. So it would parse through every 15 minutes, and if you saw there was a when does it end, we would wait 24 hours from that end time on UTC, and then we send a delete request to it, and it would go off and delete it too, which was really nice. So as you can see, and then here's all the information stuff. But in general, it's just, again, the whole point of this story is we started with a for loop, we started with bash, and we ended up just basically using bash all over again. Okay. So I lost my thing. Where'd it go? Oh no. Okay, well, whatever. So the real question out of all this is, was this worth it? Honestly. Yeah, actually it really was. After all this work, all this time spending with Mofi, learning how to do all this stuff, it was really, really, really worth it. I wish I could show you KubeAdmin. That's one of my goals is showing off KubeAdmin, but unfortunately, the VPN that I have access to do this does not like scale for some reason. So I'm not going to fight that right now. But the idea is that we built this interface that allows us to control everything from a 50,000-foot view through KubeAdmin. I can either use the automated process through GitHub Enterprise and have the queue and be able to say everything's what I expect it to, or I have KubeAdmin that allows me to fill out a form to shove it off to AWX to do the request, or when I needed to clean up a bunch of workshops because sometimes people would finish early or there would be problems and we had to restart, KubeAdmin gave me the ability to see everything and just select all the servers that we need to delete and then hit the delete button. So long story short, yes, the ability to eventually get just /approve on one of the requests, which we ended up automating. Because if it failed, if we didn't need /approve after about a month of running it, because our bot would verify everything inside the request, and if it passed all those those guardrails, and they didn't put some bad word as the name of the workshop, everything was great. So that's really it. I realized it was much faster than I was expecting, mainly because I can't show you kubeadmin because of the whatever. If you do want to take a picture of that QR code, that is a more in-depth blog post about this, and thank you. Yes, Justin. Justin's question was there anything culturally changed about it? I was in a position of privilege. I did not have a cultural change with this because it was literally me and a selected group of nerds inside of IBM that wanted to try something different. My original story was that we did basically a bash script, and that was what we were originally given. I found a little strike force, if you will, of nerds that wanted to try something different, so we got to build this over time. And legitimately, I found some real people who were looking forward, which is always nice to find inside a company.
It's a 404.
Is it really? Son of a... All right, well, I'll fix that. Just drop me an email, awesome@ibm.com. I will get you that link. You've got to love enterprise systems. So, any other questions? You can go watch Mofi's talk now.
More questions?
He's much more entertaining than I am.
I'm not familiar with IBM functions. Did you have any problems with timeouts or special things on that side for running something in serverless?
Yeah, great question. So timeouts and whatnot around. Well, so I kind of glossed over this, which was IBM functions, cloud functions, and Code-Engine are two separate products. Cloud functions were Cloud Foundry based, and it was the limitations of Cloud Foundry, where Code-Engine was Istio and Kubernetes based, where the beauty of the way we wrote the software is that it would just, the container would just spin up when the request was coming in, the beauty of Istio, right? Hey, there's something I need to do, shove it over to the group that I need to talk to. It would grab that post, send that request, it would get the 200 requests back from the API to say, yes, I got your request, and then just kill the container. So arguably, we never had to worry about timeouts because it was just basically firing off. We were using Code-Engine as that background process that we were running on that one this laptop, actually. Instead of me running it on that, we were just leveraging Code-Engine as that. Does that make sense? So, yeah.
Does it mean that now that you're here, it doesn't work?
I'm sorry, what?
You said this laptop when on running things. Does it mean that now that you're here, it doesn't work?
No, when I was saying the bash script that we used to run to do this one right here, when we ran it with the little ampersand in the background. But the beauty of this too was that this was all on the public internet. So as long as we had access to the public internet, it would work fine because all these commands, IBM Cloud, it wasn't talking to any of the blue network, is what we call it at IBM. It was all talking to the public internet. So this would work right now. I strongly suggest don't doing it, but this would actually work if you just took it and ran it.
You keep talking about this in the past tense. What are you using now?
Great question. I do keep talking about this in past tense. Well, when we were really running this, this was in a before time when we were allowed to, be at events and spending a lot of time together in smallish rooms with pizza and beer. That's slowly but surely coming back. But, and this stuff is still sitting there. Like I test it every once in a while to make sure that nothing's gone completely wrong because, I mean, what I said at the very beginning of this talk, right? How do you convince people to use software or new technology? You get fingers on keyboards. This is the foundation to be able to spin up n number of clusters that IBM pays for to be able to get your fingers on keyboards to learn something. Cool. Yeah. Yeah. Yeah, it's been a while now, so I can talk about it without getting in too much trouble. So it all boils down to, and I'll say it again, it all boils down to this line right here, that's sleep random. So I still remember the product manager, one of the product managers for IKS, which is IBM Kubernetes Service. He informed me that, first of all, at that time, I was the largest user of IBM Cloud Kubernetes Service, which was also very disheartening. Because again, what I was saying earlier at the very beginning, IBM designed their cloud to be production-like. You spin up one cluster, it lives until the cluster needs to be updated. And then it just lives there forever. Like, that's how they designed it to be, because who in their right mind is going to spin up clusters left and right? Like, you're not going to take your server and run it in and run it out. Well, obviously we all know that that's not the truth, but different conversation for different time. So when he informed me in that, he's like, yeah, by the way, here's a little bit of inside baseball about how it works. Just keep that in the back of your mind. Well, 6 months later, I was spinning up my clusters, and this is when I also discovered the limit of 75 clusters per region, was because it seemed that at that time, 100 was, like, I was going to do a workshop at, I forget which DevOps days it was one of the larger ones, and I needed 100 clusters. I was expecting about 80 people there, so I couldn't do the 75, or 75 number. I needed at least 100 to make sure that first all the clusters came up correctly, there wasn't any weird errors or nodes weren't showing up. So I requested 100 clusters. All 100 requests hit the API at the exact same time, all with my user ID. So all of a sudden, it just basically overran the etcd backend that kind of like level set across the API, according to some, or at least what I've heard. And it caused a cascading failure through the system because it overran that database. I was told after the fact that they never printed it out. They were going to print it out and actually, like, so I could put it on my wall as, like, I actually took down IBM Cloud. But I was informed by that same product manager after the time. He was like, JJ, what you did is actually highlighted one of the largest problems we had, is that you were actually marked as an internal user of IBM. So we didn't have any of those limitations that we normally put on the normal API on top of you, because why would you ever ask for more than, like, a cluster at a time? We just assumed it was fine. And I'm like, well, your process failed, buddy. And he's like, yeah, and you did cause a global outage. Exactly, I was a chaos engineer at the time. And what they told me to do is just like, JJ, put an F and sleep inside of it. Just don't run them all at the same time and you'll be fine. So, but the problem was, what they didn't tell me is that if I'm asking for 100 clusters and I'll get those 200s back, that sleep right there, because it doesn't run parallel, it runs serially, this script now would take upwards to 16 hours to run. So I'd have to sit here and have this laptop open, waiting for all of these things to come down, which was not sustainable, right? Like, and that goes back to the idea of using Code-Engine, where I can just, to Rothgar's point, I just shove that thing to the Code-Engine. I don't care, it's in the internet, right? It just has the thing. But that was the most painful part. I can go into more details when we have a frosty beverage in our hands, but I prefer not to say more because I know this is recorded.
You had said or implied that there's potentially a 20% failure rate.
Yes.
What protections do you put on that? What cleanup do you put on that? How do you keep that from causing either orphans or downstream issues?
So this was also at the very beginning of IKS. This is no longer the case. They are those failures are significantly less now, just to make that very clear on the recorded media. Yeah. But at the time, our capacity planning was the actual core problem. Because people would be requesting clusters, and the ability to spin up the clusters and the nodes and get orphan nodes was a real problem. What we ended up doing, and I don't have an example here, but we created we took the Hello World Go app from Google, I think it was, that when you just shove that manifest into a Kubernetes cluster and it responds back with like hello world and like the date and time or whatever. We ended up adding that as a sanity check after we got the green that the cluster was ready. And also that made sure that we had a real ingress also, which was the core story of this. At the time, you can get or I still think you can still, get a free Kubernetes cluster for a month on IBM Cloud, but you can't get an ingress. That was the limitation of it. So when we wanted to show off like some really neat ingress stuff, we would need to give you a full cluster to be able to do that. Like you can use like node ports and all that, but to get a real ingress, you need a real full cluster. So with all these full clusters, then we would be like, we'd take the cluster name, all the random, what's the word? Auto-generated URLs and all that stuff with that, and it would go in and create that, expect that hello world to be created, and then if we would send a curl against it, and if it came back, then we were like, oh, at least one of the nodes is up, because we always, if you notice, they're all 3 node clusters, because again, we weren't 100% sure that one of those nodes might fail, or one of them might be a problem, so we would at least need to know that one was working, the master or the leader at the time would be able to send it to at least one node, because most of the stuff was all just one-on-one stuff also, right? This was at the time when people were still just trying to grasp the concept of what a pod was, and this was all we needed. So, Rob, did I answer your question? Okay. Mm-hmm. Sorry, I get rambly sometimes. Part of my charm.
Okay, any others? Okay, that's all. Well, thank you very much, JJ.
Thank you.